Hi everyone, I am Sreekanth. We are discussing programming in C language. The topic is about basics of C programming language. The agenda of this session is about primitive data types in C language. In this session, we try to discuss in detail about floating point data types like a float type, double type, long double type with suitable examples. The previous video session, we had discussed in detail about data types like primitive or basic data types, derived data types, user-defined data types, empty or valueless data types like void. In the previous video session, I explained in detail about integer data types. In this session, we try to discuss in detail about floating point data types like float type and double type, long double type. Okay. So in the previous video session, I explained about integers like a short integral type, int type, long int type. The short int we discussed with examples like unsigned short int, signed short int. The integral data types like int, unsigned int, signed int, in the long int types like unsigned long int, signed long int, with suitable examples with min range and maximum range with example programs. Here short, int, long, these are all what keywords enabled by what C program. Signed and unsigned. Here signed bit, signed int x equals to 100. By default it is what? Plus 100. In the 16-bit memory representation, the last bit, most significant bit, 0, represents what? Positive integer. The remaining all are what? Magnitude. This is about magnitude of what? Like 15 bits, the last bit, 16th bit, most significant bit represents what? If it is 0, it represents positive integer. If it is 1, it represents what? Negative integer. Like minus 100. When we given minus 100, the most significant bit value is what? 1. It indicates what? Negative integer. Coming to this session, floating point data types. See, already integer types there. There we discussed in detail about short type, int type, long data type. Why should we go with the floating point data type? Why? Because suppose I declared one value in the integer like int a is equals to some value assigned like pi value, right? 3.142. Assume, okay? Like 3.142. I given some value. But I try to print a value with the help of integral data type. It's going to be prints only 3. It cannot print this fractional value like 142. It cannot be printed. Okay, then how to print this fractional value after decimal point values? Then we can achieve through floating point data types in C language. It can categorize again float type, double type and long double type. Okay, we try to discuss one by one with the suitable examples. Before that, we need to discuss here size and range of values for floating point data types on 16-bit machines. Here the sizes are going to be vary between 16-bit and 32-bit and 16-4-bit machines. Observe float, double, long and double are keywords in C language. The data type is what? Float data type. Occupy size 4 bytes of memory. How to represent float type? For percentile F represents format specifier of what? Float to type. The range is, this is a range about what? Float to type. And double is a keyword. It occupies 8 bytes of memory. The format specifier of double is percentile LF. Here small l, small f. The range of double type is like this is a range of what? Double type. Similarly, we go with what? Long double. The size occupies 10 bytes of memory. What is the format specifier here? Percentile L F. L is a capital. The difference between long and long double and double is the format specifier of double represented by small LF. Long double represents what? L is capital, F is small. So this is a range of what? Long double. We go with one by one. In the floating point data types, floating types are used to store what? Real numbers, like floating point numbers. After decimal point, the fractional values we can able to store and we can able to display using floating point data type. Float is a keyword. According to the standards of IEEE 754, single precision floating point. The floating point numbers with the 6 decimal digits of precision occupies 4 bytes for storage, 6 to 7 significant digits for float type. Float is a 32-bit according to IEEE 754 single precision floating point number occupies what? 1 bit for the signed bit, 8 bits for the exponent, and 23 bits for the value. Float has 7 decimal digits of precision. So this is the representation of what? Single precision. The standards of IEEE 754 floating point standard, like 1 bit for signed bit, 8 bits for exponent, 23 bits for what? Mantissa. So this is a representation of what? 32-bit representation of what? Floating point data type. Syntax: data type, variable name equals to variable value. In the previously we discussed about integer data type, but here we are discussing which data type? Float data type. Name of the data type is float. Name of the variable any meaningful identifier name. Here I given var1 is equals to some value like 10.327, like 10.327. Okay, fine. This is the example we'll discuss. First, we'll continue the topics about double and long double. At a time, we'll discuss about float, double, long double example programs. Okay. Here double is a keyword. Double is also a data type which is used to represent the floating point numbers. It is a 64-bit standard like IEEE 754 double precision floating point numbers for the value. It has 15 decimal digits of precision, 15 to 16 significant digits for what? Double. So double is a 64-bit standards of IEEE 754 double precision floating point number occupies 1 bit for the sign bit, 11 bits for exponent, 52 bits for what? Mantissa. This is a standard of what? IEEE 754 standards of 64-bit representation of what? Double type. Data type, variable name equals to variable value. Here data type is what type? Double. Double is a keyword. Double is a data type. It has a double precision or 2 times more precision than what? Float data type. Here I give a name. Variable name is a, variable value something 10.327. So this is the example and with the output of double type. Next I go with what? Long double. Long is a keyword, double is a keyword. Long double extended precision floating point. It occupies more precision values comparing to what? Double type and float type. Long double. Data type is what? Long double is a data type. Variable name is what? A. Any identifier name, any meaningful identifier name, I simply taken here A. The value is what? Something 10.327. So this is the example program with the output. Okay, so we go with one by one example program with output. So I go with the Turbo C++ IDE. I try to execute Turbo C++ IDE these programs first. Okay, see, in the previous video session, I explained in detail how to download and install Turbo C++ IDE and how to write simple Hello World program, how to compile, how to debug, and how to run. I explained in detail in the previous video session. If you missed, kindly go through that video, how to download and install, how to open, how to write, how to compile, how to run the application. Okay, see, go with the file menu. I try to create the new source file. Okay, I try to create one new source file. Here writing a commands like a float example. Okay, so I go with the header file as include stdio.h represents standard input output header file. So I'm currently writing with what? Turbo C++ IDE. So here I'm going to be use what? conio.h console input output header file for clear the screen and get the resultant output. So I go with the void main function. It is an entry point for what? C programming. So this is the structure of what? C program. Here I try to declare float. Before that, so I would like to show you something here. Suppose I try to store some value like 3.142. Okay, so observe int a equals to 3.142. I say the okay. Assign the application here. Int is a data type. A is the name of the variable. Value equals to how much I assigned? 3.142. See, this is about floating value, right? See, before compiling, I try to save this application. Can give any meaningful name. Just I'm going to be save the application. Okay, like, go with float example dot c. Fine. So once you save the application, you can able to see the name float example dot c. Fine. I'm going to be printing the application. Print f. Okay, here output screen, the output is going to be printing in the first line. Okay, I try to print in the after two cursors of new line. Okay, fine. Can take a variable or simply I take var1. Okay, like value is equals to, you can give any meaningful name. Value is equals to integral type. At present I declared what? Integral type. We'll see what happens here. What is the name of the output variable? var1. var1 is what type? Integral data type. But what type of value I stored here? Floating point value, like 3.142. After decimal point I store some fractional value, right? So compile this application, go to compile menu. You can compile. Shortcut is what? Alt F9 is a compilation. Compilation is done successfully. Run application. Shortcut is what? Control F9. Go to run menu. You can run the application, but output is coming but not displaying, right? So because I'm not written get CS, you can able to see here 2 times I run the application. Value equals to 3, value equals to 3 is coming. Okay, just a moment. Here I try to give CLR SCR, clearing the previous output screen, previous outputs. Get CH is a function to get the resultant window, output window. Okay, so observe, I try to compile this application, Alt F9, I try to run the application, Control F9. So what is the output here coming? Value equals to 3, but what value assigned to the integral type? 3.142, correct? How to print these fractional numbers? That is not possible in integers. Then we go with what? Float type, floating point type. See, one of the floating point type is called float. Float is a keyword. See, float format specifier is what? Percentile F. But I given percentile D. We'll check once what it going to be print. It going to be print output or not. So value equals to 0. So you must represent floating point format specifier only. What's the floating point format specifier? Percentile F. Okay, save this application, compile and run the application. So now we got the output or not? The correct output 3.142000. Observe here, after decimal point it going to be represent, after this point it going to be represents 6 values 142000. So this is about the 6 digits is going to be printing after decimal point. After decimal we may get what? 6 fractional values. So this is about float type. So I want to print size of float type. Here slash t represents what? Tab space, it giving a space in the output message, the between value and size. Okay, one tab space. Fine. Percentile D, obviously I written here percentile D for what? Size. How to print size of particular data type? Using a keyword size of. Here size of behaves like an operator. Size of operator, we are printing a size of particular data type. Here I'm printing float data type. Size, observe, it occupies 4 bytes. Okay, getting right? 4 bytes. Here I'm giving bytes message, 4 bytes. Next I try to print what? Address information. It's going to be store some address, right? Address equals to percentile U. Unsigned. Address always represents what? Signed or unsigned, but at present I given unsigned. How to represent address? Using ampersand symbol. Which variable? var1. Okay, save this application and run this application. Compile and run application. So observe, value equals to 3.1420006, 6 digits after decimal point. It occupies how many bytes? 4 bytes of memory. Address stores in some unique address like 655222. Got it? So this is about float example with output. So I go with another file. You may write in the single file, but I go with the new file. Okay, I try to write double example now. See, you can copy and paste the code using what? Shortcut, control insert and shift insert. Not required to write the syntax every time, right? Okay, fine. So observe, I go with the change here, simply double type. The remaining code is same, but I change here only what code? Double type. Because which data type I'm using? Double type. So try to observe. I try to save this application with example double example one dot c. Observe, double example dot c. Save this application with a double example dot c. compile this application, run this application. We got it right. The value equals to how much? 3.142. Size occupies how many bytes? 8 bytes of memory. Address stores on 65518. So what is the difference between float and double? Float occupies 4 bytes of memory, but double occupies how many bytes of memory? 8 bytes of memory. Okay. So next I go with the long double example. Okay. So go to new file. Again I go with the new file. Control insert, shift insert, long double example. Here I try to represent long double. See, I did only small modification, remaining codes are same because they are printing just value, size and address. I'm comparing both float type and double type and long double type. Okay, save this application with extension .c. By default it comes with what? .cpp because it's a turbo C++ IDE, and it comes with the default address like C drive, turbo C3 directory, subdirectory called bin, and name is called something. Okay, no name 02.cpp, but I try to write with the meaningful name long double example. Don't give any white spaces in between while saving the application. Okay, that's it, long double example dot c. Now save this application. Yes, we saved successfully. Compile this application, run this application. Got it? Fine. See why it getting like that? Because what is the value of this format specifier of the long double? Percentile. See, in case of double it is printing still percentile f, but in case of long double must be use what? Format specifier percentile lf. Okay, see, don't forget, in case of double and float it works up to the particular range percentile f, but in case of long double must be represent format specifier capital L small f. Save this application, run this application. Now we got the result, right? See, value equals to 3.14200. Size occupies how many bytes of memory? 10 bytes of memory. So observe the result, right? In case of float type it occupies 4 bytes of memory. In case of double type it occupies 8 bytes of memory, and in case of long double it occupies 10 bytes of memory. See, this is the difference between what? Float type, double type and long type. Okay, see, I go with the, this is about the simple example programs. We may work out with the various cases in this float type, double type and long type, but at present it is fair enough how to write the floated data type, how to declare, define, initialize, how to compile and run the applications. Okay, so I go with the another ID dev C++. See, regularly we are working on dev C++ ID, right? So I go with the new source file, new source file. Here I'm going to be discussing what? Floating point data type example. Okay, floating point data type example. Here I try to declare another header file called as include stdio.h, standard input output header file. See, in case of Dev C++, not required to write conio.h. See, that is required in Turbo C++. Why? Because we need to clear the output screen and we need to get the resultant output window. But in case of Dev C++, not required. Okay, so I go directly with the main function, void main function. Within that, here I'm not declaring any variable. I'm not declaring defining and initializing any value. Just I try to print the sizes. Just observe here, print f. Here size is equals to, okay, first I try to print which size? Float to size equals to percentile d. Float to size represents size. Size always represents what? Format specifier integral type, percentile d bytes. Okay, yes. So observe what happened. Try to concentrate. Using which keyword? Size of keyword. Okay, directly I'm printing size of float type instead of variable. Directly I'm printing what? Size of float type. Save this application. So you can save any directory. Here I try to create one more directory, right? New folder. Yeah, already data types I created. Okay, in the data types I try to create one more folder like float type, float. Okay, float. Within the float directory I try to save this application like example1 dot c. You may give any meaningful name. Simply I give an example1 dot c. Observe, float directory. Within the float directory, you can give any meaningful name of the directory name. Just I given float. The name of the file name is example1.c. Fine. Click on save this application. Now compile and run this application. Okay, compiling, processing. Yes, compilation is done successfully. Now run the application. Yes, we got float to size equals to how many bytes? 4 bytes of memory. Got it? Fine. Similarly, I go with the double size. Okay, double data type size. Representing what? Double size of double. I want to print size of double. Okay, compile this application, run this application. Okay, it comes with what? 8 bytes of memory. Just compare how it going to be prints in the Turbo C++ IDE. Is there any sizes are varying between Turbo C++ and Dev C++ IDE? Just I'm checking. Okay, run this application. Observe, there also float occupies 4 bytes of memory, double occupies what? 8 bytes of memory. Now we go with the long double. So I try to print a long double size. So observe, long double size of long double. Okay, just check it out what will happen here. Okay, run the application. Concentrate here. It going to be prints how many bytes? 16 bytes. But if you go with the Turbo C++ IDE, it's going to be occupies how many bytes? 10 bytes of memory. The size is going to be varied or not. See, in case of Dev C++, we are it going to be allocated about 64-bit memory representation. There it going to be allocated about 32-bit memory representation. For that sake, the sizes are going to be vary between these two IDs or not. Yes, long double occupies what? Size equals to 16 bytes. Okay, in this session, I try to give you one question. Okay, the question is that suppose I declare here one variable float, like variable 1 is equals to some value like 3.142. Okay, simple value I'm assigning here. I try to print this value. So just observe, I'm not doing much. I'm giving very simple solutions here. Yeah, I try to print here var1 value, var1. How to represent float type? Percentile f. Okay, so var1 value, or simply we can print value is equals to, okay, percentile f. I try to print here, the name of the variable is called var1. Okay, say observe, I try to run this application, compile and run the applications. As getting value equals to 3.142 in the similar fashion of what Turbo C++, how we executed 3.142.000. Fine. So I go with the next example like var2 double type var2 the same value 3.142. How to represent double type? Percentile LF. Okay, both L and small f, small L and small f, the format specifier of what? Double type. Save this application, compile this application, run this application. Yes, it is coming, it is printing 3.142.000. Okay, say observe, I go with the next type called long double type. Long double type. The variable name is called var3. The variable name is var3. Here I try to print var3. How to print long double? Percentile L. L is capital. Percentile LF. Save this application. Compile this application. There is no compile time errors. Now run the application. Observe here what happens. Getting the values are 0.000. The value is coming what? 0.000. See, everyone try to write a comment of why it is getting 0.000 in case of what? Long double. But I executed successfully with the value in Turbo C++ ID. But in case of Dev C++, I try to execute the same value, right? The long double type. Why it is getting 0.000? See, try to give the answers in the comment section. See, that is the assignment I've given to the all the viewers. Okay, fine. Here, I would like to show you some more thing. Observe. Okay, I take some variable like f1, assume. Here I taken some digits like 8, 9, 7, 5, 6, 4, like that. See how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So first we go with the 6 values: 1, 4, 2, 8, 9, 7, 5, something. Okay, like 3, 4, 5, 6, 7 is there, right? I go with the 6 value. Any 6 value, any value. Here I try to print this value. Okay, but how it going to be printing? It going to be printing what? 6 digits, right? Previously it going to becomes 142000. See, observe how it going to be prints this value. What's the name of the variable one? F1. So try to concentrate, compiling the application, running the application. It comes the value equals to what? 3.142897. Okay, see, I want to print only two floating values, like two fractional values. I don't want to print every time 6. I want only 2, or I want to print only 3 fractional values. Then how to print? So that is the next question, but I try to provide the solution here directly. See, I'm going to be commenting those values. So instead of printing directly value percentile f, I go with percentile dot how many fractional values you want. Example, I want 2 fractional values, then you can give here 2. After decimal point it going to be prints what? 2 fractional values when I given dot 2. So like you can print like 3, 4, 5, 6, like 18, like that, based on your requirement. Fine. See, compile this application, run this application. See, observe, it going to be printed only after dot decimal point. How many fractional values, how many floating values it printed? Only 2, 1, 4, because I given here dot 2, right? Suppose I given here dot 3. See, just observe dot 3, then it going to be prints how many values? After decimal point it going to be prints what? 3 fractional values. Okay, compile this application, run this application. Observe, it going to be print after dot, it going to be prints 3 decimal fractional values or not. See, this is a usage of what? Like a dot, after dot we are going to be specifying 2f. Like we can also use like a ef, like a percentile e, percentile g also. In the coming sessions we try to discuss. Up to here it is fair enough. If I go with the next things, next cases, you may get confused, but in this session I discussed in detail how to write floating point data types, like what is a float keyword, what is double keyword, what is long double keyword, what is the size of float type, what is the size of double type, what is the size of long double type in the 16-bit, 32-bit and the 64-bit. The sizes are going to be vary between what? 1 bit computer machines to another computer machines based on 16-bit, 32 and 64-bit. Okay, see, what is floating point type? Like float type, what is the most significant bit? Exponent, how much it going to be occupies? What is the value of mantissa? The float type, it occupies 1 bit for sign bit, 8 bits for exponent, 23 bits for what? Mantissa. With the suitable examples, like we go with the double type. Double is a keyword. Double occupies 1 bit as a sign bit, 11 bits for exponent, 52 bits for what? Mantissa value. In case of long double, so long double occupies what? 10 bytes of memory, 16 bytes, like that. Size is going to be vary between what? One computer machine to another computer machine. That to be here I give an example with the IDs, like turbo C++ ID, the size is varied, and dev C++, another size is going to be printed for long double type. And also I asked one question, right? Why it going to be print 0.000 in case of long double value printing in the dev C++? Okay, everyone give me a valuable comments and answer for that question. Okay, thank you for watching my videos. Thank you all.